Welcome to the Empirical Formulas workshop. Before I start, I want to make sure, is everybody hearing me well? You can message me. Awesome. So this week's experiment is empirical formulas. The objective of today's experiment is mainly to understand what is an empirical formula. It's a very simple concept that we will review shortly. The second objective is to produce a reaction. We will produce a reaction between magnesium and hydrochloric acid and calculate the empirical formula of the product. And as is listed here, we are going to verify the two main laws that you already studied. One law is the law of conservation of mass, and the second law is the law of the definite proportions. What are those laws? The law of conservation of mass basically is saying that the total mass of substances present at the end of a chemical process is the same mass as the mass of the substances present before the process took place. What is this wording? What this all means? Just to give you an example, let's say we have a beaker here. A beaker with a solution, with a liquid of, just to give you an example, of silver nitrate. And we have next to it a graduated cylinder filled with potassium chromate. We have two liquids. And I will take the mass. I will place these two liquids and their containers on a scale, and I will calculate the whole mass. And just to give you an example, let's say I do that. I place them on an analytical scale, and I record the mass, and it says that the total mass is 104.5 grams, just to give you an example. And then, after I record the weight, I will put one liquid, this liquid of potassium chromate, I would pour it inside the beaker that has silver nitrate. What am I going to see? I will see I mix two liquids and I see like a red precipitate. That is a clear indication that I have a chemical reaction. I will see a precipitate of silver chromate. After the reaction took place, I will place them again on the scale and I will record the mass of the whole thing. And the mass, it will be the same before the reaction and after the reaction. So this is what it means the law of conservation of mass. When I have a chemical reaction, the atoms rearrange. Let's say in our experiment, I will have magnesium that reacts with hydrochloric acid to produce magnesium chloride plus hydrogen. We will look at it again later. So what is the law of conservation of mass? I will weight the amount of magnesium before the reaction started. The same way I weighted in this scale before I mixed the two solutions, and the mass was 104.5. In our experiment this week, we will measure the mass of magnesium before the reaction took place. And then we will measure the mass of the product, which is a solid, white solid, after the reaction took place. And we know that the mass of the magnesium, the initial mass of the magnesium before the reaction took place, will be the same as the mass of the magnesium in this compound, because we do not create matter. We do not create magnesium. The atoms rearrange. So when I will have the weight of the total, I know that after the reaction took place, I would say that the mass of the magnesium after the reaction took place plus the mass of the chloride equals the mass of the product, magnesium chloride. So I know, because of the law of conservation of mass, the initial mass of the magnesium. It will be the same. And I know the mass of the magnesium chloride because I weighted after the reaction took place. So all I had to do is calculate the mass of chlorine, that it will be the difference of the mass of magnesium chloride and the mass of magnesium. We will do some examples and we will go over the report to make sure that you can complete it. So basically that's the idea of the law of conservation of mass. Because we don't create matter, we can calculate the empirical formula. And it says that also we are going to verify the law of definite proportion. What is that law? That law is very simple. It says that the name of a compound is always associated with a specific ratio of elements in that compound. What is, in simple words, what this law means? Means that if I have water, let's say I have this molecule, H2O. We all know that this is the molecule of water. So what do I see in this formula? I see hydrogen and oxygen, and I see a ratio of 2 atoms of hydrogen and a ratio of 2 to 1 and 1 atom of oxygen. Every time I see a formula H2O, is going to be the same name and the same compound. It's going to be constant. But if you see this formula, yes, it has the same elements, hydrogen and oxygen, but in a different ratio. 2 hydrogens per 2 oxygen. And that is a different name, which is hydrogen peroxide, and it's a different compound. So this is what the law of definite proportion is saying. Any questions? Okay. Okay. So now this we are going to, here they are giving you an example of how you are going to calculate the empirical formula. This is an example, a different example. It's not what you are going to do in your report. They give you just how they calculate when they have a reaction between magnesium and oxygen to produce a compound. Let's say the subscripts are X, magnesium X, and oxygen Y. So you are basically reacting the magnesium with oxygen, and this is just another example. And they are saying, okay, the mass of the magnesium in the compound, I know because it's the same as I had at the beginning. But what is the mass of oxygen? Because I am going to record the weight of the whole compound. The mass of the oxygen is going to be the mass of the compound minus the mass of the magnesium. So this is an example that we are not doing. The example that we are doing is here, the one that is explained in this procedure. So all we are going to do is prepare, try to, even though you are not going to do it in the lab, we are in the virtual experiments, you still have to learn the setup and the parts of this is a Bunsen burner, and you still need to get familiar with those. So watch the videos that will teach you how are the names of the Bunsen burners and other information that you might need to know. But what is this experiment about this week? It's very simple. What are you going to do? This, what is in here, you are going to take an evaporating dish. And this, what is on top, is called watch glass. So you are going to first record the weight of an evaporating dish and the watch glass, empty. And then you are going to add on the evaporating dish a ribbon of magnesium, just solid magnesium, metal, shiny, and you are going to weight again the whole system, magnesium plus the evaporating dish plus the watch glass. And you need the weight of the magnesium, because you are going to need that information to calculate the empirical formula. So all you have to do, because you are not doing it, you are going to be given that information. So first, the experiment, as I said, is weighing just the empty watch glass and the evaporating dish. Then you add the magnesium, you weight again, and you calculate the weight of magnesium. Then you are going to add some drops of hydrochloric acid. And then you are going to see bubbles. You are going to see bubbles, and you are going to see that the magnesium disappears because there is a chemical reaction. We're going to add before you heat. This is after, before you start the heating, you are going to add some drops of hydrochloric acid. And you are going to obtain a compound that you already know what it is. Let's write the correct formula. and hydrogen gas. This is the chemical reactions once you have the metal magnesium and you add the hydrochloric acid. Now, what is the objective of today's experiment? Is basically, let's say that we don't know that this is a 2. We have an X and we have a Y. Empirical formula will be the calculation of this X and this Y. We know now that X is 1 and Y is 2. You saw this reaction in the previous experiment. So you are going to add hydrochloric acid and you are going to see the bubbles. That is the gas, hydrogen gas, that is formed. And you are also going to see that the metal, the solid metal, is going to disappear and is going to form this product, the magnesium chloride. And this hydrochloric acid is aqueous. How do you know the reaction is complete? You know because when all the magnesium that you had reacted, you won't see any more magnesium solid. You will see just the product, which is a white solid. And what else is an indication that the reaction is complete? You are going to see that there is no more bubbles, no more hydrogen here. So then, once you see that the reaction is complete, you are going to start the heating using this Bunsen burner, and all you want to do, because the hydrochloric acid is aqueous, is to evaporate all the liquid and end up with the mass of magnesium chloride. So you are going to warm until you see a white solid that is dry. If you don't wait until the solid is dry, what happens? Your weight is higher. You are weighting your magnesium chloride plus some water. And you are going to assume that all is magnesium chloride. So your empirical formula might not be correct. So then you wait until it cools down, because we cannot use the balance if we cannot place on the balance anything that is hot. It has to be a room temperature. We wait until everything is at room temperature, and then we are going to record the weight of the compound. So this is all it is, the experiment today. And then here is the indications, and let me see here. Okay, this is, we are going to see this later. And then we are going to calculate the empirical formula. Now we are going to share, I will share some practice to make sure that you are ready to go to the report. Please interrupt me and send me a message if you have questions. This is very informal. Okay, now I will need your help. I need your help to solve these practice problems. Let's look at the first one. Which formulas below are empirical formulas? So what is an empirical formula? An empirical formula, we said, that is the lowest whole number ratio of the elements in a compound. So let's say I have this formula, and I will ask you, is this an empirical formula? Well, this is the molecular formula. This is the formula of benzene. This is how one molecule of benzene looks like it. But empirical formula is not the molecular formula. It's the lowest whole number ratio of the elements. That means I have here a 6 and I have a 6. Is this the smallest? No, I can divide both 6. If I divide by 6, I will end up with the whole numbers, but the empirical formula will be carbon hydrogen. So now let's look at A, carbon 2, hydrogen 6. Is this an empirical formula? Can I divide both? Yes, exactly. We can divide everything. Very good, John. We can divide everything by 2. If I divide 2 divided by 2, I get carbon 1. Exactly. We don't write the 1, so it will look like carbon hydrogen 3. Very good. Let's look at B. Is this an empirical formula? Potassium permanganate. Is this an empirical formula? Can I find a number that I can divide? It is an empirical formula. Great. Awesome, John. Let's look at the next one. Is this an empirical formula? No, very good. Exactly, thank you. Let's look at the next one. Well, I already did it. Carbon 6, hydrogen 6. This is not an empirical formula, and the empirical formula will be carbon hydrogen. How about the next one? Is this an empirical formula? This one. Yes, it is. Because I cannot divide by, I have a 2 and I have a 3. If I divide by 2, I don't have whole numbers. So then it is an empirical formula. How about the next one? Hydrogen peroxide. Is this an empirical formula, the F? Very good. This is the empirical formula. And how about the next one? Is this an empirical formula? Very good. Excellent. Excellent. Very good. So this is a good practice. Let's go to practice number 2, because you are going to need this in the pre-lab quiz, and I think you will have to learn this to do your report. So let's read this question. It says 0.245 grams of powdered copper metal is roasted in oxygen. So they are giving me the mass of the copper. And they are saying that the copper metal reacts with oxygen to obtain a product that is copper X oxygen Y. So what I have to do is find this X and find this Y and write the formula of that compound. And it says the product is weighted and found that is 0.304 grams. And they ask you, what is the empirical formula? So you know the steps. You know that at the beginning, it says that you have 0.245 grams of copper. And it says that at the end, I weigh the product and I have 0.304 grams. So when you are calculating the empirical formula, the first thing you have to do is look at the product, and you have to have the grams of each element in the formula. In other words, we need to know the grams of copper and the grams of oxygen in the compound. Now I'm asking, what is the mass of copper in the product? What is the mass of copper that I will have in the product if the reaction went to completion? I will have, that will be the mass of oxygen. Exactly, very good. This is the mass of oxygen because it's the difference between the mass of the product minus the mass of the copper. So the mass of the copper in the product is going to, now I'm referring to the product, in the product is going to be the same mass that I started originally. So the mass of the copper is going to be 0.245. And what is the mass of the oxygen? I calculated as you did. The mass of the oxygen is going to be, because I have the mass of the whole product minus the mass of the copper, I calculate the mass of oxygen, and I get the same as you, 0.059 grams of oxygen, and this is grams of copper. Very good. This is the first step. I have to have the grams. Second step, you know that the formula, these subscripts are not grams, are moles. So we have to convert the grams into moles in order to calculate these subscripts. So how do I convert the grams of copper into moles of copper? You know that the number of moles of copper is very easy. You just divide by the atomic weight. How you convert grams into moles? The only way to convert grams into moles is to divide by the atomic weight. So let's calculate the number of moles of copper. Well, we have the grams, 0.245 grams of copper. And we know that 1 mole of copper, because we go to the periodic table and we look at the atomic weight, and we see that the copper is 63.55 grams. So when I do that, I get a number. My number, the number of mole of copper, is 0.00386 moles of copper. And then I have to do the same for oxygen. I don't have that much space. I will go here, and then I'll erase it. Number of moles of oxygen is going to be what? I look at the mass, that is this one, 0.0059 grams of oxygen. I go to the periodic table, and I know that 1 mole of oxygen is 16.00 grams of oxygen. And this, I obtained a number that is 0.00369 moles of oxygen. Now that I did the step 2, what does that mean? I'm very close to the empirical formula now because I had to calculate the X and Y. And I know the atoms are copper and oxygen. And what did I calculate? I said that the number of moles of copper is 0.00386, and the number of moles of oxygen, I got them here, equals 0.00369. But I'm not done yet, because the empirical formula doesn't want these numbers, wants whole numbers. So all I have to do is, that is the easiest part, look at which of these two numbers is the smallest. In this case, they are almost the same, 0.00386 and 0.00369. So the 369 is smallest number. So I divide both numbers by 0.00369 in order to get just whole numbers. So the empirical formula, I will get both, and I round it to a whole number, and I will get this empirical formula. Just 1 and 1, but we don't write that. Any questions on this example?
Would you go over that last step again, please?
Sure. I think I have no more room. Let me see where I can write. So the last step, yes. Can I erase the whole thing?
Sure.
Okay, I will do that because I need space. Okay, so I don't know why this color came, but okay. Okay, so what we said is, first we calculated the grams. That was easy. Then we said grams doesn't work in the formula. We have to convert it into moles. And that is easy because we use the atomic weight. And we ended up with copper. We said, I think the copper was 0, let me find another color, 0.00386 6. This is the number of moles that we calculated. And oxygen, we had a number very close, 0.00369. These are the moles that I calculated for oxygen, and what it means is that I have this number of coppers this is the molar ratio, but because the empirical formula wants whole numbers, what I have to do is find which one is the smallest number. So in my case, they're very, very similar. 369 and here 386. So I will pick the smallest number, which is 0.00369. So for oxygen, I will do 0.00369, which is the number that I obtain, divided by, have to divide both by the same number. In this case, I will divide by 0.00369. And I obviously, I'm going to get a 1, because all I did is, okay, I'm going to divide both numbers by the smallest number. The smallest number is the one that ends in 369. So I divide 0.00369 by 0.00369, and I obtain a 1. This is going to be the subscript for oxygen. And then I do the same for copper. What number did I have for copper? I had 0.00386. But I have to divide it by the same number, which is 0.00369. And the number that I will obtain is 1.05, but I have to round it to the closest whole number, that is 1. And these are the subscripts. Basically, this is 1 and this is 1. So for copper, the subscript is 1. So when I write this, the X for the copper is 1. I don't write it because we don't write the 1. And the oxygen, if I let's say I would have gotten a 2 for copper, I would write copper to oxygen. And this is the empirical formula. But I didn't get that. I got 1 and 1. So I have to write copper oxygen. Did I answer your question, John?
Yes, if you, let's see. I was going to say if you got copper 2, I guess if you divided it to break it down to the empirical formula, you would get the same thing anyways. But the correct answer on the test, if we come up with a number, we still have to break it down if needed for the empirical formula.
Right, because if you write 0.00, you are not giving the empirical formula. You are giving a good ratio, but the empirical formula says that is the whole, for the empirical formula are whole numbers. It says it's the lowest whole number ratio. And that's why it's a math, it's another step, but it's a mathematical step that you do it to obtain the ratio in whole numbers.
Yes, thank you.
You're welcome. Okay, so I don't know why this is in violet now. I cannot get rid of that, but that's okay. Okay, look at the last practice. It says, what is the chemical equation for the reaction between magnesium and hydrochloric acid? You saw that in the previous experiment, and I already wrote it. And it says, how do you know the reaction is performed to completion. So who can tell me what is the reaction between magnesium plus hydrochloric acid, which is the experiment that the reaction, we are going to obtain a white powder of magnesium chloride that is a solid plus hydrogen gas. And here goes a 2. We balance the equation. So this is the chemical equation. And obviously, you know how to write magnesium chloride. But you are going to verify that when you calculate the empirical formula for magnesium chloride, you have to obtain in your report for magnesium a 1 when you divide by the smallest number, and for chlorine, you need to get a 2 because this is the right formula of magnesium chloride. Since you know the formula, you can check. When we do research and we don't know and we are in front of us an unknown compound, it's not that simple. But now you are going to verify that the subscripts correspond to the correct formula of the magnesium chloride. And then it says, how do you know the reaction is performed to completion? Okay, 2 things. First of all, if you want the grams of the magnesium in the product to be equal to the grams of the metal magnesium before the reaction took place, you have to wait until all the magnesium is gone. Otherwise, your assumption is not correct. So one way is looking at your evaporating dish and make sure that all the magnesium solid disappear, is dissolved, and is converted into the product. This is one sign. The second sign, if you see this is hydrogen gas, which means you are going to observe bubbles of hydrogen. So you have to wait until no more bubbles are formed. So this is the second indication that the reaction went to completion. Any question? So now we are going to share the blank report to make sure it's a very simple calculation, but just to make sure that you will know this is a simple lab, so try to get the maximum amount of points possible. There are not that many calculations. Every person will get different data. So let's say this is how it's going to look when you open your report. And they will give you, the first thing, the mass, you know what the experiment is about. So they will give you first the mass of the watch glass and the evaporating dish by itself, just the cyst empty. And then the same thing with the magnesium on it. And then they will give you, because you are not doing this experiment, they will give you the mass of the watch glass, the evaporating dish, and reacted magnesium after cooling. So basically the mass of the product plus the mass of the watch glass plus the mass of the evaporating dish. So see, there are not many calculations that you need to do. So let's look at the first one. Look at my data. It says calculate the mass of magnesium. How are you going to calculate the mass of magnesium in your report? Very good. Excellent, John. Yes, exactly. It's going to be, with my data, 0.24. Because what did John do? He did 51.61 minus 51.37. He did the mass of the watch glass, evaporating dish, and magnesium, and subtracted just the empty watch glass and evaporating dish. Very good. How are we going to calculate the mass of the product? What is the mass of the product? We are going to do the same thing. We have the mass of the product plus the system, and we don't want to know the mass of the watch glass and evaporating dish. We just want the mass of the product. So what are we going to, what is the answer? We are going to do 52.32 grams, which is the mass of the product, plus the mass of the evaporating dish, plus the mass of the watch glass, minus the mass of the watch glass and evaporating dish, which is 51.37. And we are going to obtain a mass of product of 0.95 grams. All we want is mass of the product. So we had to subtract the empty watch glass and the empty evaporating dish. Very good. Then they will ask you the mass of chloride. What is the mass of chloride? How do we calculate? We saw that by difference. We saw that the mass of magnesium, we know, because it's the mass of magnesium in the product is the same as the mass of magnesium at the beginning. And how do we calculate the mass of chloride? We have the mass of the product. We know that the mass of the chloride plus the mass of the magnesium equals the mass of the product, right? So the mass of the product is 0.95 grams. We have that data. And the mass of the magnesium is 0.24 grams. So if I subtract in both sides the mass of magnesium, the mass of the chloride equals the mass of the product minus the mass of the magnesium. Any question? So what is the mass that you calculate for chloride with my data?
.71.
Okay, thank you. 0.71 grams. Very good. Okay, so now I have, this is the first step when we calculate the empirical formula. The first step is to calculate the grams of the elements in the compound. And we have the grams of magnesium, that is 0.24. And we have the grams of chloride. Very good. But now, because in the formula, we don't use grams, we use moles, we have to convert the grams into moles. And they are asking, calculate the moles of magnesium in the product. Okay, how do I calculate the moles of magnesium? I go, the number of moles of magnesium is going to be the grams of magnesium. And then I go to the periodic table. And what do I find? I find that 1 mole of magnesium, the atomic weight, equals 24.3050 grams. So when you do that calculation, what do you obtain? How many moles of magnesium? Let's see if you have a calculator. 0.00987. Okay, I'm gonna write that 0.00987. Thank you. And now let's do the same for the chloride. So I need the moles of the chloride. So then it's going to be number of moles of chloride is going to be, well, I'm going to erase this. It's going to be the mass of the chloride. I look for the mass. I have it here, 0.71 grams. And then I will use the atomic weight of the chloride, that is 35.4527. Okay, so, and then what do you obtain? How many moles? What number did you get? Okay, 0.02. Okay, 0.02. Very good. So now I'm very close to the empirical formula, because all I have to do is to look at which number is smaller. I have this number, 0.00987, the number of mole of magnesium, and the number of moles of chloride. And obviously, the smallest number is 0.00987. So what am I going to do? I will do for magnesium. Now I'm trying to find, let me get a different color. I'm trying to find the subscript for magnesium. So how am I going to do? I get the number of moles of magnesium, 0.00987, and I divide that number by the smallest number of the two, 0.00987. And I get a number 1, and that will be the subscript for magnesium. Now I will do the same for chlorine. I'm looking for the subscript for the chlorine. And I look at the moles of chlorine. John calculated that it was 0.02, but I have to divide by the same number, that is 0.00987. What number do you get in your calculator? Yes.
Oh, sorry, I jumped ahead there a little bit.
No, that's good. So it seems that you got a 2, right?
Yes.
Okay, so we rounded to a 2, and that is the subscript for chlorine. So our formula, that I don't have a place to write, is what you wrote, is, let me see where I can, okay, can I erase this? So we got 2 for chlorine and 1 for magnesium. So here they will ask you, enter the empirical formula for your product. So we calculated that magnesium is 1, and we don't write the 1. And for chlorine, we calculated the subscript 2. So this will be our empirical formula. And then it will be good if you can, it looks like it's 0 points, but you can upload your work if you want. That depends on your teacher. Any questions? I will stop the recording, and I want to thank everybody for being here, and I will stay after I stop the recording in case you have questions. Thank you.